Sagar from AML B section, holding the pin number of 25955 so my topic is about memory sharing and isolation in a virtualized environment in AT Tech Talk videos. So the introduction in a virtualized okay in a virtualized environment, multiple virtual machines or containers share the same physical hardware. So, memory sharing allows them to use common memory pages effectively, reducing duplication. Memory isolation ensures that each virtual machine's data stay private and protected from others. The challenge here is balancing efficiency, sharing, and solidating isolation. Visualization allows multiple operating systems to run simultaneously on a single physical machine using a hypervisor like virtual machineWare ESXi, KVM, or XN. So memory management is crucial because every virtual machine believes in it has own full memory, but they'll all share this same physical RAM. Memory virtualization layers. The memory virtualization layers guest virtual address GVA used in the virtual machine. This guest virtual address GVA used in virtual machines and a guest physical address GPA. What the virtual machine thinks is physical memory. So virtual may or this virtual machines does not need the physical memory addressing, but it should have some space or it should have some physical memory for creating the virtual environment. Host a physical address. This is actually physical RAM managing by the hypervisor. Hypervisor. Memory sharing. The memory sharing has some techniques in virtual machines. The kernel chain page merging KSM or TPS, that's a transparent page sharing, identifies the identical memory page across virtual machines, keeps one shared copy in memory. All virtual machines map to the same page as read only. One modification: copy on read COW creates a private copy. This is a kernel same page merging. This is called that. And another technique is memory duplication. Periodically scans pages and merges identical ones. For example, multiple VMs running the same OS share common library pages. Next, ballooning. Ballooning is the adjustment of a virtual machine's memory dynamically by reclaiming unused pages from idle virtual machines and giving them to others. Useful in overcommitted systems, total virtual memory is greater than physical RAM. Next, the virtual memory isolation. Sorry, the memory isolation or the virtual memory isolation. Virtual memory monitoring (VMM). This is also known as virtual hypervisor protection. Enforces strict page table separation. Each virtual machine has its own virtual to physical mapping. Hardware assigned virtualization. Intel VTX, AMD-V. These are some virtualizations hardware assistance. Like ensure no across access. Next, hardware support. The hardware support we need to install these is uh, IOMMU, that's input output memory management unit that prevents direct devices access from here to unauthorized RAM memory. Next, copy on write and read only pages. Even shared pages can't altered by other. sorry. Even shared pages cannot be altered by other VMS without triggering a private copy. Sandboxes and access control restricts hypercalls and memory mapped IO to prevent data leaks. Security layers, encryption of VM memory, example AMD Save and Intel TME prevents host or other virtual machines from reading sensitive data. So advantages from these is strong isolation ensures security and stability because we have some security layers like encryption of virtual machine memory, and the trade-offs are less sharing, high memory consumptions. This concept a high memory of copying the data and copying the private data and triggering it. Next, trade-off sharing isolation. So here the aspects are the like memory sharing, memory isolation. What's the differences between this? If the in memory sharing, the efficiency is deduplicated, but in memory isolations we have security and privacy. The mechanism is defined by page deduplications. COW. COW means that copy on write. Here we have already read the thing that a copy on write. And here the isolation has hardware isolations, page tables. Page tables are the very simplest topics in hardware isolations. Also causes the same thing. Next, benefits. What are the benefits by using memory isolations? That in memory sharing we save RAM. There are more virtual machines, but in memory isolation, it prevents the private messaging leaks and maintains some sustainability, and it creates a decent line that should not be crossed. And the risk in memory sharing is side channels attacks, and here in memory isolations are reduced efficiency. The efficiency is reduced in memory isolation. A balanced design using sharing within secure context, like same tenants, and isolation between untrusted virtual machines. Here, there are some modern solutions for this. Secure duplication. Page sharing only between trusted virtual machines. This can secure much duplications and reduce the space complexity, and like it can reduce some space, or it can reduce some RAM in it. And encrypted memory. Hardware based pre-virtual machines encryptions. AMD, Save, Intel, TDX are the basic examples for these hardware based VMs that encrypts virtual machine data, and container level isolation uses namespaces and CG groups, less strict than virtual machines but lighter weight. This lighter weight has meaning, a deeper meaning that the RAM may be slower in this, and the applications of these VMs, the cloud computing, AWS, Azure, GCP. It's cloud computing is nothing but the virtual memory we can create, and in simple way we can use the virtual memory by using this cloud storage. We can access this cloud storage by various platforms. It safely run multiple customers on same hardware. It contains only same domain, and it has the same hardware, and it connects multiple users to the same domain, and it can give a separate environment for a separate for customer, and its IoT systems efficiently memory reuse in this limited environment, and data centers maximize memory utilization while keeping tenants isolated. Here, when When the tenants are isolated, the memory is utilized more. And finally, the conclusion for this is in virtual systems, in virtualized systems, memory sharing enhances efficiency, memory isolation ensures security. So we have to use both. A well-designed hypervisor balances both by using like page deduplication for trusted workloads, strong hardware isolation for untrusted workloads, dynamic techniques like ballooning and memory encryption for flexibility and safety. Thank you, ma'am.